What's up YouTube? Today I'm going over the F5 TTS installation and fine-tuning / training tutorial, and we're going to be doing everything in Python today, so no packaged version of it, but I'm going to give it a demo of it first, and then we'll go into installation. So here we go. I've got an audio file already loaded. I've already generated a sample, but I'm going to resynthesize this, so I click synthesize. It generates pretty fast, but I'm also on a 4090, so here we go. And first we'll take a listen to the reference audio, and then we'll listen to the output. So this is Gideon from Elden Ring, and let's take a listen.
I understand you've been speaking to Nepheli. She's my daughter. I took her in when she lost the guidance of grace.
So reference there, and here is the outputted audio for that sentence.
He didn't say any more, but we've always been unusually communicative in a reserved way. And I understood that he meant a great deal more than that. In consequence, I'm inclined to reserve all judgments, a habit that has opened up many curious natures to me and also made me the victim of not a few veteran bores.
So I'd say that the zero shot for F5 is kind of unparalleled right now. It's really good at zero shots, but that isn't what we're interested in today. We're interested in how we can train it, how we can fine tune it. So we're going to do that. And I do just want to show it in another language as an example that you can train other languages. This model is still training, and it's been quite long with 6,700 hours of audio for the training. So I'm going to just play some audio samples from here for a sentence in Japanese, and then we'll jump into installation. So this is Rosawall from ReZero, so let's take a listen to that.
硬い地べたの感触を顔面に味わい、彼は自分がうつ伏せに倒れたのだと気づいた。
So there we go. That sentence was said pretty good. The model, however, still isn't perfect. One thing that you'll find with F5 TTS is you need to train it a lot, and there's a lot that goes into it that I'm still figuring out. But regardless, let's go ahead and jump into how you can install this. And yeah, so we're going to head into GitHub, and there are a few things that you're going to need. These tools here, so Python 3.11, which open up here, go down to the installer, which is this Windows 64-bit installer, run through that, and make sure you add it to path when you see a checkbox for that. Git, so go ahead, download the installer here, 64-bit, run through all default options for that. And then you need to install FFmpeg on your computer. You can go ahead and watch a YouTube tutorial on how to do that, and that will be how you set up your machine for this. And then you will need an NVIDIA GPU with more than 8 gigabytes of VRAM. So training F5 TTS is very compute intensive, and it's not for the faint of heart if you don't have a lot of GPU power and a lot of time. So it's going to take a lot of time to train a model in this, but that's what you're signing up for. All right, so to install this, we are going to be doing this in a virtual environment. So some of the steps here are out of order, so just follow what I'm doing in the video. You're going to want to open up a Windows File Explorer, and I usually like to split my windows side by side so that I can copy and paste things, so it makes things a little bit easier. And then we're just going to right click and then open in terminal a PowerShell window, or you can just go to the address bar up here, type in CMD, that'll do the same thing. But open in terminal for that guy. And we want to clone the repository first. So go into this bottom area right here, number 2, git clone paste. And then we're going to want to change directories into it. So cd f5 tts. So that'll bring us into that directory. And then we want to check out what hash I'm on right now. And I'll put this in the description so that you guys can just copy it down there. But what I'm doing right now is I'm going to git check out the repository at this specific hash just to make the video kind of frozen so that you guys are seeing the same thing in the video, even if this video is being watched like a year in the future. So I'm going to check that out, and so we're in this detached state here. So let me just type in CLS, which will clear the window, and we can continue with the rest. So now we need to make a virtual environment. I like to use 3.11, and this is how I like to create it. And then we'll do venv scripts activate. So go ahead and do all of that, and if you did it successfully, you should see venv here. If you're running into any issues with not being able to activate the venv, search online how to change your execution policy from something. You need to change it to remote signed. So just search up how you can do that online. And then now we're going to install PyTorch. And to do this, you just copy that line and paste that in there, and it's a pretty big download, about 2.7 gigabytes. I already have mine cached, so it's going to be pretty quick, but you guys will just be waiting just a little bit for it to install. And once that finishes up, we can now go down to here. So we don't need a big vgan in this installation. That's just a different vocoder, which is supposed to have higher output quality. And we don't need that for this tutorial, so we're not going to install it. But in the case that you do, I'll show that in a later video. So now we're just going to install the package in editable mode. So clear, and paste that in there, and we should be good to go. So this will take a little bit of time, and then our virtual environment should be set up and we should be good to start training. Alrighty, and that is all you need to get started with F5 TTS. Now, we will need a bunch of audio files and some samples to train off of. So I'm not going to show how you can curate that, but you can do whatever you want to get some audio files, download off of YouTube, download from Hugging Face, so on and so forth. But I already have kind of this test data set right here. So if we just full screen this, you can see there's some pretty big files here. I've got 6 English ones and then 7 Japanese ones. So we're going to be using about 20 hours worth of data for this to try to create an English-Japanese model. And yeah, I'll show you guys how to set that up once we launch the fine-tuning Gradio interface. And so now copy this line right here, F5 TTS fine-tune Gradio. Paste it into the window, and it's going to launch open a local server on 7860. So navigate to localhost 7860, or you can left control and then click the link and it'll open up here. And that'll bring us to this Gradio interface here. So this time around, I didn't create this. So this was actually due to the credit of IPSCR right here. So thank you very much for creating that Gradio interface for us to use. And yeah, I'll show you how you can use this for training. So we need to set up a project. So leave this at Pinion, and for project name, we can name this whatever. I'm going to call this test YouTube, or actually I'll call it test in J. So English and Japanese. And then I'm going to click create a new project. So that's going to give us this name right here. And that's going to give us a new folder inside of F5 TTS. So if you double click into F5 TTS, into data, you're going to see that this folder has been created. So what we now need to do is move those audio files into this folder. So we'll go and copy these files into there. So F5 TTS, data, test dataset, and then we're going to paste that into dataset here. So those files are going to move, and then we can start getting this all set up. So this transcription process is going to take a little bit of time. So we'll do audio from path because I already have the audio files downloaded, and you can see we're following the format here. And I just realized I have some English and Japanese samples, so I'm going to have to do this in a little bit of a different way. But yeah, so let me create a different project. I'm going to call this Japanese. I'll create a new project for that, and then we'll select that, and then I'll paste those Japanese files into the dataset folder here. Now I'm going to process this with the language Japanese, and then click on transcribe. So that's going to start running through the process, and it's going to take quite a bit of time for this to complete. So just give it some time, and we'll be back once that is finished. And you can observe what's happening inside of the command line terminal right here, or you can just watch it process right here. All right, so this process is all complete, and I've got all of the transcriptions. So I can now go into vocab check, and then I'm going to check the vocab just to make sure that all of the words that are inside of the dataset, all of the letters, aka tokens, are present that we're using to train. So I'm going to check the vocab, and it says that the following symbols are missing in your language, which are a bunch of different kanji characters, it seems like. And so what I can do is I can just double check that real quick by going into this meta.csv. And yes, I do have a bunch of kanji characters in here. And so all of those different symbols are missing from the vocabulary. But I don't actually want to train with kanji, so I'm going to go and do some pre-processing real quick outside of this repro to convert all of that into hiragana. So I'll be right back and then I'll rerun this. All right, luckily I have this Tortoise dataset tool script, and the CSV file follows the same format. So here we go. I've got all of it in hiragana, which is going to give me a nice standardized alphabet that I can use. And I'm just going to now rename this to metadata CSV, and we're going to use that file. So delete this old one, paste the new one in there, and yep, voila, I've got it all in here. So if you're not doing Japanese, you probably could just ignore those last 30 to 40 seconds, but that is needed for Japanese just because of the way the language works. And then so now I can hop back into here and then do check vocab, and it's going to give me a more reasonable 25 characters or symbols are missing in your language. So here we go. Now I'm going to just click on extend, and that's going to make the vocabulary .txt that we need for training a little bit longer. It's going to make our tokenizer longer. And then it's also going to extend the model that we're using to the size of the tokenizer. So if you're confused by what that means, basically it's going to make sure that the model is capable of being trained with the tokenizer. So that's all it's doing. And then now we'll go into prepare data and we'll prepare our data. So we'll just click on this prepare button and it'll go through the process for that prepared data. So here we go. It's going to purge all of the bad data out of the data set. And then we can now go to train data and we can start getting ready for training. So to get started first, you can just do auto settings here. And then it's going to give you the number of samples that you have inside of your data set. And then for batch size type, we're going to stick with frame. And so the way this is formatted is a little bit interesting. There are some of these tabs in here that aren't being used. Some of these boxes aren't being used. So just follow kind of step by step what I'm doing here. So batch size, frame, fine tune, yes, leave token file, tokenizer file, and path to pre-train checkpoint empty. F5 TTS is what we're training. Learning rate, leave the same. Batch size per GPU, I think it changes based on what your GPU is or how much VRAM you have. If you have 8 gigabytes of VRAM, you're going to be starting at 1,000. And you can actually kind of check what they're using or for recommendations if you go to their CLI here. So you can see batch size per GPU, 1,600 for 12, 2,000 for 16, and 3,200 for 24. I can actually crank this up to 4,000 for my GPU, which is a 4090, which has 24 gigabytes of VRAM, and it'll be fine. And don't worry about max samples here because we're using frames up here. Gradient accumulation steps, leave at 1, and then epochs you can set to whatever amount you want to. Now, 724 I think is quite a bit of training that's going on. So maybe we'll need 724 epochs, but I'm going to put this down to a number like 500, and then we'll leave that there. And then save per updates, I'm going to put at 5,000. And then last per steps is basically how often to save a checkpoint for your model. So in case you need to restart, it saves a previous state. We'll put 1,000 there. For mixed precision, we'll do BF16 for my GPU. I believe Ampere and Ada Lovelace 30 series and 40 series cards can use BF16. If not, just use FP16. If you run into any issues with that, just go with none. But I'm going to use BF16 here, and then I'm going to use TensorBoard. So I just remembered as well, there's one additional thing that we do have to do if we're going to use TensorBoard, and that is pip install TensorBoard. So you'll need to hop back into a virtual environment. So we'll just open this in terminal. Once again, venv scripts and then activate. And then we can do pip install TensorBoard, and we should be good to go. We can now just do that F5 TTS. Sorry, it looks like it's fine-tune TTS with a dash between fine-tune and Gradio. So that's going to launch back up, and then we can go back into our browser. We can actually just leave this here, so just wait until this is finished launching up. We don't have to refresh or anything because no code changed, and we can continue setting up some things here. So now all we need to do is just click on start training and everything will get up and going. So we'll hop back into the terminal just to make sure there are no errors. And that should be pretty much it for training. All right, so there you go. Training is now running. And you can see the amount of memory that's being used in my GPU. We've got 14 out of 24 being used here. And now you just kind of let it sit and train for a long time. So this is going to take a while. So a few things to note. If you're training a new language, you'll probably need to train for about a day to two and then start listening to the model, see how it comes out. And you may need more than 10 to 20 hours of audio. For example, in the one that I'm training in for Japanese, I'm using 7,000 hours of audio to train that one. So quite a big number. And then if you want some details and information for people that have been working with fine tunes, head over into this forum or this discussions area right here and scroll through here and read up on some things. But there are a ton of people working on this right now, just trying to get it through. And you might be a little overwhelmed if you try to read everything in here, but you can find some good discussions going on in this fine-tune practice area. But otherwise, this model just requires a lot of training. I'm going to leave this overnight and then see how the model turns out in the morning, just to kind of see what happened. And all right, so here we go. Training is all up and finished. And I actually did a little bit of a miscalculation last night. This actually only trained to 180k epochs. I need to do 1,000 for a million epochs. So bad mental math on my end, but we have finished that model and we can go and now test it. So I'm going to crank NFE steps up to 64. The higher the number here, the higher the quality. I believe you can do 64 and 32. And then there's a speed slider here, but we won't need to use that until we check out the output of the model. So I'm gonna click refresh here and I'm gonna choose the latest one, which is this 180k.pt file. So I'm gonna save that. I'm gonna grab a random sample and then go and inference off of this. So let's see what we got after about 180k steps of training on about, I'd say, 10 or so hours of audio. All right, so let's take a listen to this sentence.
シシロボタンがジョインしましとか言ってて、たらびっくりするやろ普通に。
That's actually not too bad. So that's the first time that I've done a small scale training. So maybe I need to focus a little bit on small scale training instead of the large scale one. But let's listen to the reference sample here.
シシロボタンがジョインしましたとか言って出たらびっくりするやろ普通に。
Alrighty. Well, that actually came out not too bad. Let's re-inference and try to listen to it one more time. And then I'll try to do it with a different piece of text.
シシロボタンがジョインしましたとか言ってて、たらびっくりするやろ普通に。
I mean, that's surprisingly good to me with such little training data. But, and one quick little post note that I do want to add, that this doesn't do too well with zero shots. So it does very good with speakers that are in data. So speakers that I have trained on. But if I upload an audio here that wasn't in the data, for example, Razawal from ReZero got a short little clip here.
私がこの屋敷の当主。
Got that. I'll paste in the text for the reference, text for audio reference, and then I'll try to generate here. We're just going to get a bunch of gobbledygook here. So let's take a listen. So it just kind of sped through that. The model doesn't actually know how to speak in the speaker's voice. But if I go and grab a random sample from the data set and then try to now generate with that, the result is going to be much better. So let's take a listen.
硬い地べたの感触を顔面に味わえ、枯れ葉自分がうつ伏せに倒れたのだと気づいた。
So not too bad, messed up a little bit, but we'll take a listen to the reference audio.
チーム大人っていうのがちょっと。
So pretty close in my opinion. And I guess if you're actually just trying to train on a single speaker voice in another language, you might not even need to have a large pre-trained model to do so. You can just train directly on that speaker, and the result seems to be pretty good. I'll have to do a little bit more testing on that. However, if you're trying to get the same results as the zero-shot cloning capabilities of F5 TTS, you probably will need to train on many thousands of hours of diverse speaker data. So zero shot, it didn't do too well, but on the fine-tuned speakers, it actually generalized to the language. So that was pretty cool. So we have successfully fine-tuned the model on Japanese with only about 10 hours of data. And of course, you could train a little bit more to see how far you can go. I do want to just try out one more thing real quick, see if it can still speak English. And so let's pull some of the Great Gatsby out of here and try to inference on that. So what happens if you start to train the model in another language is that it starts to lose kind of how the first languages or the base languages that were in the model sound. So let's see if it still maintains some of that.
そしたら、するやるつに、he didn't say anymore, but we've always been unusually communicative in a reserved way, and understood that he meant a great deal more than that.
Okay, so that's saying it kind of had some bit of the input audio, and it speaks in kind of like a thick Japanese accent. Let's try that one more time.
普通に、he didn't say anymore, but we've always been unusually communicative in a reserved way, and I understood that he meant a great deal more than that.
Okay, so it's still pronunciating English correctly, but it's starting to mess up a little bit. And that's only going to get worse and worse the more that I train in Japanese, because I don't have any English data in the training data. So only Japanese here. All right. And after training, you probably want to reduce the checkpoint so that it's not 5 gigabytes large. So all you need to do is just find the path to the file. So in Windows 11, you can just right click and go copy as path. We can just do properties, copy this, and then you'll just need to paste the model name in there after. We can paste that path into path checkpoint, remove the quotations, and then path to output. We're just going to do the same thing. And because I want to output it to safe tensors, we are just going to now change this to safe tensors, and we should be able to reduce. So we're going to do reduce, and then we should see an output here that says new checkpoint saved here. So we're all good to go. So now we can go into the folder, and we have a new file, which is 180K safe tensors. And then we should be able to use this model as well for inference. However, the checkpoints drop-down menu right here doesn't yet allow you to use that. So I've got to add that modification into here. So if you do want to just try to test that out, you can just unclick safe tensors and then just rename it to something else. And then we can just say reduced. And then we can test out this model here if we want in the test model tab. So just refresh, and then we'll be able to find that reduced.pt, find a random sample, and then infer off of this. So here we go. Let's just take a listen real quick.
バイ人類の先祖が未だにカナダな原種哺乳類だった頃。
Alrighty, so there we go. It is outputting in Japanese, and that is pretty much how you can fine-tune on F5 TTS for another language. And there are a lot of little nuances that go into it, such as training data, how much data to use, how long to train. All of that stuff is being explored right now, so I don't have definitive answers for that. So you'll just have to try out some things to see what works out best for you. All right, so that's going to be it for today's video. Sorry, it's been a while, but I've been actively working with F5 TTS and just doing some things on the side for some of the projects that I'm working on, just to move them forward. And yeah, that's pretty much what I've been doing for these past couple of weeks. And well, that's gonna be it for today's video. Once again, I'd like to thank all the members of the channel for supporting me, and I very much appreciate it. So I'll see you guys later.